pressure relief valve, which we have seen earlier in different lubrication systems. The operation is, this oil comes from pump and goes to the main system, and if there is any exceed in the pressure of the lubricating oil, again this spring loaded ball will fall down, and here is small path where it is written to oil sump. The extra oil which is under high pressure will be drained back to the oil sump, and the tension of this spring can be adjusted by this lock nut and adjusting screw according to the requirement. Next part is the oil filter. The purpose of this device is to filter the oil and supply it back to the oil sump. The construction is, this is a chamber, and within this chamber there is a filter element. This is in 360 degrees. We can imagine this is the cut section, and this filter element is round if we imagine it into 360 degrees, and oil comes from here to this annular cavity from sides. It will not come directly here, it will goes to here, and after passing through this filter element towards inside, here is a perforated metal tube. Perforated metal tube means there are small holes, very small holes into this tube, and after filtering from this filter element, the oil goes to this perforated tube, and from here the clean oil goes to the gallery. Here is a drain plug. When after some time the products of wear and tear or impurities get stored here in this chamber at the bottom, we can drain it from this drain plug, or otherwise we can also replace this whole filter assembly. Next, there are some ISI specifications and brand names of engine lubricants. ISI specifications for IC engine lubricating oil are according to IS Indian Standard 496 of 1966, and these standards describe the lubricating oil for IC engines under all climatic conditions in India. There are different types of grades, and these are classified into oils with high viscosity index are written as HVI, oils with medium viscosity index are written as MVI. Here are 5 grades of high viscosity index. This SAE is the Society of Automotive Engineers, grade 10. This oil is SAE 10. WHVI, the W word here will represent winter season. That means this grade of oil is suitable for winters. Similarly, SAE 20 grade oil is of high viscosity index. We can see the specifications of these various grades under the IS standards, and 2 types of regular oils comes under each grade, regular and premium. Regular is for regular use and premium is somewhat better than the regular. Next is the medium viscosity index oils. Similarly, here SAE 20 MVI, that which shows that this is the medium viscosity index oil. This viscosity indexes will decide the application of this lubricating oil. Similarly, regular and premium standards comes under each grade of the oil. Next are the oils for heavy duty. So, under this we will use the suffix HD. Again, SAE 10 WHD indicates that this oil is of 10 grade and is suitable for heavy duty and is also suitable for winter grade winter season, and these oils are of heavy duty with different grades. And there is there is an extra heavy duty oils with which we will use the suffix EHD, and W denotes the winter season. There are two types, type 1 SA30 EHD and SA50 EHD, and the second one is WEHD2 and EHD2. There are different grades. The grades of lubricating oil with suffix W are meant for winter, and the grades without suffix W are meant for the seasons other than winter. So, these are the different grades, and we can again see the different lubricating systems of the engine. This was the first type of lubrication system which we have seen, was purely splash lubrication system, in which the splash plays the role for the lubrication of the engine parts, in which oil troughs were there. Oil pump receives oil from the oil sump through strainer, and this is the oil gallery which is responsible for always filling these oil troughs. These oil troughs remains always filled, and these scoops provides splash when they go through this oil, and this splash gets scattered all over the moving parts and provides the lubrication. The second type of lubrication system was the combination of splash and pressure. Here again, for providing splash there are no oil troughs, but nozzles are provided here, 1, 2, 3 and 4, and also the galleries are provided up to the point of lubrication. You can see here the gallery all over there, the camshaft, and this is the nozzle, and the oil gets splashed from this nozzle. This system will be called as splash system, and when the oil galleries are provided up to the point of lubrication system, point of lubrication, and then that will be called as the pressure lubrication system. That is why it is called as splash and pressure lubrication system. And the third one was the pressure feed lubrication system, in which the splash is not there. There is no role for splash, but the oil galleries are provided up to the point of lubrication. And also there is a feature that oil holes are drilled inside the crankshaft. Oil is provided up to here, and because the oil is under pressure, the oil automatically goes where it finds the way. From here it goes to this crank pin, and from here it goes to both of the crank pins, and from here it comes here. So, there is no need to provide every point at the crank pin, and also the oil goes under pressure to the bearings of the camshaft as well as the tappet and cam assembly for providing the lubrication. Next system of lubrication which we have seen was the dry sump lubrication system. The dry sump lubrication system, as told earlier, is used for aviation lubrication system, because the aeroplanes or the jet engines, they get inclined every now and then, because while taking off and while landing they are at an angle. So, if we provide the previous lubrication systems to this aviation lubrication system, it will not serve the purpose, because the level of the lubricant will always be different at different angles. So, for that we will provide dry sump lubrication system, which will always provide the lubrication under pressure at every instant. Here we can see that the supply tank accumulates all of the lubricant, and here is the oil pump, here is the pressure leaf valve which we have seen in detail, This oil pump takes oil from this supply tank, pressurizes it and gives it to the oil cooler, which will bring down the temperature of the lubricating oil, and it will provide it to the bearings and the different parts of the engine. After lubrication, it will come down to the dry sump. From this is just a container, it will come to a dry sump, and from here again a scavenging pump takes away this oil through this strainer and again gives it to the filter, from where the impurities get filtered here, and there is also a filter bypass pressure relief valve. If the pressure gets increased, it will again bypass the oil and provide it here. So filter will filter the lubricating oil, separates the impurities and cleans the lubricating oil, and this oil will again be supplied to the supply tank, and this supply tank will always get filled with lubricating oil, and these two pumps will provide a continuous supply of the lubricating oil to the engine. This was the oil pressure relief valve which we have seen earlier. In this, the oil is coming from pump and it goes to the main system, but when the pressure of the oil increases, it will press this spring loaded ball toward downwards, and here is the path to oil sump. The extra pressured oil is given to the oil sump, and the oil will flow at a regular pressure, and the tension of this spring can be adjusted with the help of lock nut and the adjusting screw. This is a gear pump which is responsible for pumping the oil from the sump and providing it to the galleries of the oil. This pump comprises of two gears meshing with each other as shown in this diagram. They are meshed with each other, the lobes are meshing with each other. One is the driver and one is the driven. When these two gears rotate, a vacuum is created in this chamber. Due to this, oil is sucked in, and these gears, when rotate at some RPM, they compresses it. These are the small cavities, these are formed. Oil gets filled in here, and when these rotate, the oil gets compressed at pressure and will be supplied to the gallery. Here also a pressure relief valve is provided, which is again a spring loaded ball. Here is a small screw from where you can adjust the tension of the spring. When the high pressure wire goes here, the ball will be raised against this spring, and the high pressure oil will pass through this bypass line again towards the intake, and this is the intake line. This high pressure oil will pass toward this bypass line and goes to the intake line, from where these gears again intake the oil, and hence with this system the oil will be compressed and will be supplied at a continuous pressure to the oil gallery. And this type of pump is called as gear pump, which the main function of which is to supply the lubricating oil at a constant pressure to the oil lubrication system oil gallery. So students, thank you very much for listening to this lecture. I hope you have learned some principles of lubrication and the various systems of the lubrication system which are employed in automobile engines. Thank you very much.